All right, ladies and gentlemen, here we go. Section 1 of Chapter 5. Welcome to what we call quadratic functions. Oh yeah, baby. There's a lot of stuff we're going to do with this particular unit. And first things first, though, let's start with the basic vocabulary. So we're going to use this foldable. We're actually going to live in this foldable for about the next 4, 5, 6 days and continue on with this knowledge of graphing quadratic functions and what the actual basic vocabulary is throughout the next several weeks. So let's dive into this quadratic functions foldable, and we'll go first of all to the basic vocabulary flap. So if you flip open the basic vocabulary flap, you're already going to see on there a coordinate plane. And I'm going to have an example here. You scroll down. So you can jot this example down if you want to. You're going to have to pause this. But I already have the actual basics of what is the vocabulary that you're going to need to know, if you will, for quadratics. So here's the first one. A quadratic function, by definition, is a function or equation where it has any type of a degree 2. That means the highest exponent that it has is a 2. So something that's squared. If you get into something that's cubed to the 4th power, to the 5th power, to the 6th power, that's not a quadratic. They're called something different, and we'll get to that later. But degree of 2, so here's some examples down here. I'll box them for you. So you can see, yes, there's all kinds of terms in this equation right here, but x squared, that's a quadratic equation, quadratic function. This right here is a quadratic equation because there's an actual squared on it. So there's your basic definition there. Now when we graph these things, as you just saw in the inquiry lesson we did in class, any of these that we graph, they all look like this U shape. And that U shape, as we talked about in class, is a special name. That's called a parabola. Now sometimes the U shape actually can go down. It can go like this. Sometimes it can be very, let me erase that. Sometimes it can be very, very narrow like this. Like that. Sometimes it can go, really, really wide like like that. Regardless, it is always going to be a U shape, whether it's be, a really, really stretched U shape or a wider, whatever U shape, or a thinner U shape, or it goes up, it goes down. Either way, it's going to be a parabola, no doubt. Over here, there's something called the axis of symmetry, which actually goes along with the vertex. I'll talk about the vertex first. The vertex in this example up here is the actual lowest point of this graph. So when you're graphing it from left to right, it kind of bounces off this point and comes back up. That is the lowest y coordinate that you see or that will ever happen in this particular this graph. So it's the lowest y coordinate. I should put that and put chord. And this, by the way, is just the basic graph of y equals x squared. That is all it is. Okay? So this down here is your vertex. It's the lowest point, or it could be the highest point, the maximum, if we had a graph that went something like this. Like if it went up like this and back down, well then great. This point right here would be my maximum, aka it's called the vertex. Regardless, though, with that vertex, there is this thing called the axis of symmetry. That axis of symmetry is the vertical line that passes right through the vertex. So it's not there, but I'm going to dot this just so you can kind of see the idea. It's actually like we had with the incision point that we had with piecewise functions. Either way, that line right there, that vertical line that goes down right through the vertex, on either side of that, you're going to see a mirror image. So where this dot is, you go the same amount on that side, that's where that dot is. You go 2 over on the right side here, you go 2 to the left hand side of there. So if you go from here over, they're all mirror images of each other across the axis of symmetry. So there's some basics of what that is. By the way, this thing down here to the right, if you're wondering, it's just the XY table that came about from me plugging in x's to this particular y equals x squared equation. Just how the order pairs came about and where you're seeing these dots over here come from. So there's your basic vocabulary. So let's dive into, real quick, 2 examples. One example of how we actually graph an equation, a quadratic equation, when it's in what we call vertex form. And then we'll go over here and graph one where we have it in intercepts form. I'll give you a couple ideas, but you're going to need to for sure study this. Listen to this video twice, at least this part for sure, of how to get the vertex, because I'll have a couple steps for you, no doubt. But in terms of, understand it big time, because when we come into class, you're going to be using your notes here to be able to apply these notes to graphing these things and mastering how to graph vertex form and intercepts form. But they're all going to look the same. They're all going to look like U's. They're either going to be up, they're either going to be going down. So you at least know that is going to be the shape of these things. So let's do it. So let's do this example, and let's actually go back to your folder here just to make sure we're clear where you're going. Go to this flap that says Vertex form. So let's graph these functions when we're given something in Vertex form. So here's your example. You're going to see two coordinate planes. One says figure 1, one says figure 2. We're dealing with figure 1 with this example here. So it's y equals 2, and then in parentheses x plus 4 squared minus 5. So what I want to do is graph this bad boy. Now you all know this because right away what we know is the actual vertex, because that's what we just talked about in class with the inquiry lesson, that since this is in vertex form, we immediately know opposite of h, same as k, gives us the actual vertex. So in this specific example, I know the opposite of that, which is -4, and then the same as this, which is -5, gives me immediately, the vertex. So at -4, -5, bingo, there is my vertex. So that's step number 1. Immediately, since it's in vertex form, man, know what the vertex is and plot it. Step number 2. Now remember we talked about this from before. We're going to use this a value and determine whether this goofy little U shape, the parabola, is going to be going up like this, or if it's going to be going down like that. Remember, a positive a value means it went up, and a negative a value means it goes down. So when I look at the a value here, it means it's going up. And I'm going to tell you this is really a step I would do. So down here, what I would do, I would just draw a small little smiley face. Yay, so you know this is going to be a happy one. You know what's funny? It's a positive a value. Positive people are usually happy. They're always smiling. So a positive a value, you put a little curve right there. So that means this right away, if you want to know this, is actually the minimum. This right here, the y value, is the minimum that this graph is going to go. Why? Because the parabola is going to come down something like this, bounce off of this vertex point in a U-shaped form, bing, and bounce back up. So this spot right here is the bottom, the minimum value of the actual parabola. That's all cool. So that's step number 2. So now step number 3 is where the work comes into play, because you actually have to see how wide or how skinny this actual parabola goes. So step number 3 is to take another x value somewhere on either side of the axis of symmetry and actually do a little mathematics, plug in the x value here, and solve the whole entire thing, evaluated, if you will, sorry, for whatever y is. And that's going to give you another ordered pair that's going to be on this parabola. So first of all, let's go back to this, I should say, not first of all, next thing. So what we know is that right here, I'm going to draw this nice and, if I can, right down through here, this part, if I could dot it I could, but I'm going up through it. This yellow line is your axis of symmetry. So that's your cut line. So you know on either side of this line, this parabola is going to be a mirror image of it. So whenever I go over here, I'm going to go on the other side of it. That's my mirror image. So here's the scoop though. So since this axis of symmetry goes right through -4 here on the x-axis, I want to take another x coordinate that's somewhere close to this axis of symmetry. I'm not talking down here. I'm talking up here. This is where my axis of symmetry goes through the y or the x-axis. So I want to take either -3, -2, or -1, or the other side, -5, -6, or -7. I don't want to go over here and choose 7 because that's not even close to where my axis of symmetry intersects the x-axis. So I'm going to choose -3. So let's say I put in x is -3 and into this particular function equation, and I want to figure out whatever my output y is going to be. Here comes the work. Let's take -3 and I'll substitute it in to this equation so everything else stays the same. So I'll put -3 in for x right there. So +4 stays the same, squared stays the same, -5. So now all I need to do is use my order of operations, guys, and evaluate the right side of this equation and get whatever y down here is going to be. So let's do it. In parentheses, I do this first. So -3 + 4 gives me 1. So that's still squared. I didn't do that yet. Don't fall into the trap. I know if there was a student sitting here, they'd say, hey, can I multiply 2 times 1? I'd say, no, because that's not the order of operations. I have to do parentheses, exponents, that's next. So I have to do the 1 squared, which would give me just a 1. So that means the squaring of a 1 gives me 1. And now I can do my multiplication and division. So I get 2 minus 5, and then I can do my addition or subtraction. So that gives me negative 3. So at negative 3, weird, negative 3, that is a second point, negative 3, on this parabola. And by golly, it should certainly make sense because, remember, I got a smiley face coming up here, so my next point better never be below this minimum value. It better be bouncing back up and going this way. So that's pretty cool. So now I'm going to use my mirror image and bounce this bad boy right over here on the other side of the axis of symmetry. Oh, it looks like a smiley face. Oh, cute. So that's cool. So now all I have to do is do this one more time. I don't want to just grab it yet because I want to make sure I'm on point with this. So now I just use x as negative 3. Let's bounce over here and use x as negative 2. And let's plug that in. So I'll put it over here. So we'll go negative 2 as the x, and I'm looking for this particular y coordinate. So I put negative 2 in for the x value, so I'm saying negative 2 is what x is. I plug it in here, y equals 2, then in parentheses negative 2 plus 4, square that bad boy, minus 5. So let's do it. So I get y equals, in parentheses I get positive, well that's ugly. I get positive 2, because negative 2 plus 4 gives me positive 2. And now I got to square this thing next, my order of operations. So I get 2 times whatever 2 squared, which is a 4. And then I keep going, which gives me an 8 minus 5, which means I get y equals a positive 3. So at negative 2, positive 3, negative 2, positive 3, there's my next point. And again, it should make sense that it's up there because, again, I'm looking for a U shape that bounces off of here and keeps going that way. Mirror image that bad boy over there. And now you can start to really kind of see how this nice little U shape is going to form up. So I'm going to come down here. Bear with me. I'm using a mouse to draw this. Bing, bounces off of that. It comes back up that way. It's pretty close. Not his best. Not my best work right there. Wow. So there you go. So if I could do that again, why not? Let's try it again. So I come down here, bounce off of there. Bing. Bounce right up to there. That's a little better than the last one. So it looks just like that. So there you go. So you got your U shape. It makes sense because its A value is positive. The vertex is negative 4, negative 5. That makes sense. So it looks like a nice little U shape right there. Rock and roll. Okay. So there's your vertex. Now let's go back to your foldable and let's do one in intercepts form. So let's give you a one that looks like this. And say put your finger on that, open up the intercepts flap, and yes, you're going to see again one more ordered or coordinate plane. You're going to see two, but we're going to use the first one. Here's the example. So it's in intercept form. So negative 2 times x minus 1, and then times all that x plus 3. So there's the two quantities, the two binomials, and this goofy thing out there. Well, here is the first thing that I would do in graphing intercepts form, because immediately, remember from class, immediately what I know if something's in intercept form is I know the x-intercepts immediately. So remember though, it's this. The intercept is the opposite of P and the opposite of Q. So these are in parentheses just like it was for vertex form right here, where I went opposite of this one to get my actual vertex. You do the same here. It's the opposite to give you one of your x-intercepts. So I go opposite of that. So at x equals a 1, opposite of that, I'm actually going to get one place where this U shape is going to cross the x-axis. And then the other one is this one. So the opposite of that, which is negative 3. So at x equals negative 3 over here, that's going to be the second spot where this particular U parabola is going to cross the x-axis. Now, here's the deal. You can look at this and determine, okay, my A value over here is exactly like it was in the vertex form. If my A value is negative, then by golly, this thing is going to be going down. So that's the same thing. If the A value is negative. If I have a positive A value, then you know the U shape is going to be going up. That's going to be consistent amongst all the ones that we do. So you don't know exactly where it's going to bounce off of yet, but you at least know that the parabola is going to be going down. So it's going to look something like this, something downwards like that. Or maybe it's going to be really small, it's going to go like this. Either way, you know it's going to be going through these points, bouncing off of something and coming back down. Okay? You now, step number 2, have to determine, this might be even step number 3, really. I'd say step number 3. You have to determine where that bounce point is. So the whole goal, guys, is to find out the vertex. Oh boy. So where does that vertex occur? Well, here's what's beautiful about this whole thing. Where the vertex is going to occur is always going to be right directly between your two x-intercepts. So you have to find the middle, which happens to be right here. You have to find the middle of where those two x-intercepts are. So at this particular point, ooh, what am I drawing? That's right, I'm actually drawing a really squiggly line. But that is going to be my axis of symmetry. Woo! So I know my vertex is going to occur somewhere on that particular line. Wait a minute. That means this. If my vertex is going to occur on the axis of symmetry, which is the x equals -1 line, that means my x-coordinate for the vertex, has to be -1. That is beautiful. So I got that much. Now, how do I determine what the y value of the vertex is going to be? I know the x value is -1, because that, again, is where my axis of symmetry is going through the x-axis. So how do I determine that? You got it. I'm going to plug in the -1 in for x and for x and evaluate it for y. Beautiful, people. Let's do it. So let's take this -1 and we'll put it in for x there. Yuck. We'll put it in for -1 right there, or x right there, and we'll put the -1 in for x right there. And then we just have to use our order of operations. So I get y equals -2, and then in parentheses I'll get a -2 for that one. In parentheses I get a +2 for that one. So I just, oh, now I'm down to multiplication. So -2 times -2 gives me +4, and then times 2 gives me an 8. So that means my y-coordinate for the vertex is at 8. Beautiful. Let me use red. So at -1, 8, that's up here. And again, ladies and gentlemen, that should make sense because now I got my frowny face. Oh, my frowny face is looking like that because, again, I have to come down here and touch my x-intercept and come down here and touch my x-intercept. That is cool. Now, I'm going to tell you, for this x-intercepts form, I am okay. This is going to make some people kind of curl in their skin. I'm going to be okay with you saying you have enough points because you have the idea of which way it's going. You know it's going down because the a value is negative. You know exactly where it crosses the x-axis at these 2 points because it tells you that in the intercept form. And now you know the vertex. So I'm really okay, guys, if you just kind of take this bounce point and pull this bad boy down here off the bounce point and make it go through as long as you keep it going this way, like that. That's good. Bounce point here, coming on down, goes through the x-intercept and keeps on going that way. That is awesome. So you got your vertex up there. By the way, that would also be called the maximum value. Why is it the maximum? Because that's the highest that this graph ever goes. That's the highest that the graph ever reaches. And it goes through these two x-intercepts. So awesome. I'm going to tell you, I'm going to beg of you, go back through and make sure that you watch those two again. Please make sure you have everything written down. Please make sure you have all the steps written down because you have no chance of being able to master these in class if you don't at least watch this at least twice to kind of get the idea behind what it is. Okay? So at least have the steps down, at least have the examples written down because, again, we're going to practice these bad boys a lot in class. So there you go. I'm excited to master these things with y'all and help you do it. Later.